Lesson 85, solve problems using the Pythagorean theorem. So let's review what the Pythagorean theorem says. It says if a triangle is a right triangle with legs of length A and B and the hypotenuse of length C, then A squared plus B squared equals C squared. So this formula makes use of the Pythagorean theorem. So here are your legs. The legs always form the right triangle or the right angle. So if you square the A and you square the B, that will give you your hypotenuse, which is your C squared. So let's take a look at an example here. So let's use the Pythagorean theorem to find the missing side lengths and find side length C. So here, my A, my B, or you could say this is your B and this is your A. It doesn't matter which one you have as your legs. So I have 6 squared plus 8 squared has to equal C squared. 6 squared is 36. 8 squared is 64. We need to find out what C squared is. 36 plus 64 is 100. 100 equals C squared. To find what C is, we need to undo the square by finding the square roots. The square root of C squared is C. Whatever I do on one side, I must do on the other. So the square root of 100 is 10. So we would say that the side length for C is 10. Next one, we have our legs right here. Remember, the legs always form the right angle. So we can say this would be our A, this would be our B. So we have T squared plus 4 squared equals 7, which is our C squared. So we got T squared plus 16 equals 49. To get T squared by itself, I need to subtract 16. When I do that, I get T squared equaling 33. To undo a square, I find the square roots. So the square root of T squared is T. I need to find the square root of 33, and it says I need to round to the nearest tenth. So square root of 33 is 5.7445. So one decimal place, that would put it at 5.7. So make sure you read carefully how they want you to write your answer. This one they asked you to the nearest tenth. If they would have said just keep it as a radical, then we would have just used the square root of 33. Next one, use the Pythagorean theorem to find the missing side length here. So we need to find out what K is. K is one of our legs because it forms the right angle. So we have K squared plus our other leg, which is 5 squared, has to equal the square root of 61 squared. So K squared plus 25. Square root of 61 squared is 61. To get K squared by itself, I subtract 25 on both sides. I'm going to end up with K squared equals 61 minus 25 is 36. Undo a square by finding the square roots. Square root of K squared is K. Find the square root of 36, that would be 6. Now you could have a negative root there, but because we're dealing with lengths, we use only the positive. So this would be a positive 6. The next one, here we're trying to find the hypotenuse, so our M. So we have A squared, or 8 squared, plus your B, which is 12. So 12 squared equals M squared. So 64 plus 144 equals your M squared. 64 plus 144 is 208 equals M squared. To undo a square, we find the square roots of both sides. And here it says in simplest radical form. So now I need to break down 208. I know that I can break this down as a square root of 4 times the square root of 52. And I can divide 52 by 4, so square root of 4 times the square root of 13. Square root of 4 is 2. Square root of 4 here is 2. 2 times 2 is 4. I know I have a 4. And then all I have left is the square root of 13. So our answer would be 4 times the square root of 13. Next one, determine a right triangle. So we can use the converse of the Pythagorean theorem, which says if a triangle has side lengths a, b, and c that satisfies the equation a squared plus b squared equals c squared, then the triangle is a right triangle. So that means if you can use the Pythagorean theorem and it works, then it's a right triangle, because the Pythagorean theorem only works with right triangles. And then we have the Pythagorean triples, which just means it's a group of 3 non-zero whole numbers for A, B, and C that represent the lengths of the sides of a right triangle. Two triangles whose side lengths are Pythagorean triples are shown below. These are all non-zero whole numbers. So we cannot have any radicals in there, not have any decimals. It has to be non-zero whole numbers. Let's take a look at some examples. So determine whether these form a Pythagorean triple. So these are, the first two are your A's and B's, and the third one is your C. So if I do 9 squared plus 40 squared, that should equal 41 squared. 9 squared is 81. 40 squared is 1600. And 41 squared is 1681. Well, 81 plus 1600 does give us 1681. So yes, this is a Pythagorean triple because each of these numbers is a non-zero whole number. Next one, we have 8 squared plus 10 squared has to equal 12 squared. 64 plus 100 should equal 144 if it's a right triangle. This gives us 164. C squared is 144. They're not equal, so no, this is not a right triangle. Therefore, it cannot be a Pythagorean triple. Next one. We got 7 squared plus 11 squared has to equal the square root of 170 squared. So we got 49 plus 121 has to equal 170. Well, 49 plus 21 does equal 170. So yes, it is a right triangle. But no, it's not a Pythagorean triple. And the reason why it's not a Pythagorean triple is because this is not a non-zero whole number. We have a radical here. So yes, it's a right triangle, but no, it's not. It does not form a Pythagorean triple. And the last one, we already know that this is not a Pythagorean triple because of the square root of 65. Well, let's solve to see if it's a right triangle. So we have 4 squared plus square root of 65 squared has to equal 13 squared. So 16 plus 65 has to equal 13 squared, which is 169. 16 plus 65 is 81. 81 does not equal 169, so no, it's not a right triangle. And let's go through some application problems. The ladder in the diagram satisfies the 1 in 4 rule, a rule of thumb for the safe use of ladders. This rule states that when the bottom of a ladder is positioned X feet from the base of a building, the top of the ladder should reach a point 4x feet or 4 times feet off the ground. Find the length of the ladder in the diagram. Round your answer to the nearest tenth of a foot. So here we can use our Pythagorean theorem because we have a right triangle here. So it's 5 squared plus 20 squared has to equal c squared. So 25 plus 400 has to equal c squared. So 425 equals c squared. To undo a square, I find the square roots. So the square root of 425 is just to the nearest tenth, so it would be 20.6. So 20.6 feet would be the answer. That's how high that's the length of the ladder from ground to the top part. And our last one, the ladder leaning against the building satisfies the 1 in 4 rule for the safe use of ladders. The bottom of the ladder is 8 feet from the base of the building. The top of the ladder touches the building 32 feet above the ground. Find the length of the ladder to the nearest tenth. So if this is our building, here's our ladder, forms a right triangle. We were told that it's 8 feet from the base of the building and it's 32 feet above. So now we take our 8 squared plus our 32 squared. That will have to equal our c squared. So we got 64 plus 32 squared is 1024. That has to equal our c squared. So 64 plus 1024 gives us 1088. It says round to the nearest tenth, so the square root of 1088 gives us an approximate to the nearest tenth. We have 32.98. This 8 tells you to round this 9 up. So we would say about 33.0 feet. So that is our lesson today on solving problems using the Pythagorean theorem.